Hi, I'm Matt, and this is a Addo Multo Model 113 mechanical calculator. This is from the early 1950s, and I've just finished repairing it, so I thought I'd do a little demo on how it's used. The Model 113 was the top of the Addo Multo range. It has auto reverse, tens carry and back transfer, and we'll look at all of those as we go. So what we've got is an input register. This shows you your input number, which you set using sliders here. This is the reset for it. This is the revolutions counter. This basically counts how many times have I turned the handle, as you can see. This is the results register, where your results appear. That resets these. So let's do some basic maths. Let's do an addition. Say if we put in 123 up here, we can check that we've got the right number there. And obviously we turn the handle. A positive turn adds that to our register. We can reset and put the next number in. Let's say we put in 321. If we add that to 123, obviously we get 444. You don't have to reset every time, you could just pick the next number. So if I add 444 to 444, 888. And you can see the revolutions counter is counting each time we turn the handle. So we can add some more to that, say 687 to 888. We get 1575. All the tens carries are dealt with automatically. That's 4 additions. So additions, very simple. You just input the number, turn the handle, and you can reset with this. Subtraction is similar. I guess if you're turning the handle this way for addition, you turn it the opposite way for subtraction. There is an extra step though. Let's say, for example, if we're going to put in a big number like 10,000. Now we're in addition mode because we've added 10,000 to the register, but we want the auto reverse to be in subtraction mode, so we're going to reset this half of the slider but not this half. What's this called? The carriage. We'll reset this half of the carriage but not this half, and that's what that button does. So we can do that. So we've now got our number in here, reset the input, and we can start our subtractions. So let's say if we were to subtract 999 from 10,000, turn the handle backwards, and we get our result. We've done one subtraction. You can see, even though I'm turning the handle the opposite way, this is still counting up for us. And we have a red dot has appeared here to show us that we're in subtraction mode, which is nice. So we can then go through and do all of our subtractions. So you can subtract some more numbers, just subtracting random numbers, and you can see we've done 3 subtractions and this is our result. Very simple. You can obviously combine additions and subtractions. If you put in another number, 1331, we can add that to 5,122, reset, and then we can go ahead and subtract 1,511. Obviously it just does it, keeps track of the result in the results register. So additions and subtractions, all very easy and basic, and we reset. So how do you do multiplications? Well, think of a multiplication as just being lots of additions. So if we take a number like 12 and we add it once, we get 12. We add it a second time, 24. Add it a third time, a fourth time, a fifth time. So it's just continue to add it. That's where the counter comes in handy. We can just keep an eye on this. What we've done here, 12 multiplied by 5 is equal to 60. So what if I wanted to multiply, say, 12 by 25? Do I have to turn the handle 25 times? Well, no. We could move over to the tens column using the controller here, and now you can see we're pointing into the tens column, which effectively we've moved this over, so all we're doing is adding a 0 to the 12, which is multiplying it by 10 by adding it into the tens column. So I can turn that a couple of times. We've now done 12 multiplied by 25 is equal to 300. Very handy. And obviously you can use numbers as large as you like for that sort of thing. Let's say if we wanted to take 125 and cube it. So 125 times 125 times 125. Well, we know how to do the first part. Twice into the tens, once into the hundreds. So we've now got 125 multiplied by 125, and the answer is 15,625. So now we want this number up here so that we can multiply it by 125 again. We could just write it down and put it in, but obviously mistakes can happen. That's what the back transfer is for. We reset, press the back transfer button, and you'll see a red flag has appeared here, and this little button has popped up. This allows us to cancel the back transfer if we decide to, but we don't want to do that. So we press the button, the red flag pops up. Now when we do the reset, you can see that our result has been transferred back up here into the input section, and everything else is cleared. So we can now multiply this by 125. So the 125 cubed is this very large number here. So back transfer is very useful for that kind of thing, and other things as well. So we can reset that and reset that. So we do another little multiplication. Let's say it's 12.3 and we want to multiply that by, say 22.2 or something silly. There we go. So we've got one decimal place here, we have one decimal place here. This multiplied by this is this, so rules tell us we need two decimal places here. So let's multiply this by 12.3 multiplied by 25.2, 309.96. So multiplication is very basic, but let's have a look at what we've got and logic it out. If we're saying that, well, where are we? This number here multiplied by this number here equals this number here, well then logically we could say that this number here divided by this number here is equal to this number here. So we can do our divisions by using this as the output register. Okay, so we can put in our starting number here. Let's put in 144. We copy that down to here. So we've got 144 in here. We need to clear this side and this side, so we can do that and put in our number 12. So now we just subtract 12 from 140. The auto reverse will make this counter up for us, so we'll get an answer. So subtracting 12 from 144, and we've made it down to 0. So we've subtracted it 12 times. In other words, we've said 144 divided by 12 is equal to 12. But that was a lot of turning of the handle. There must be an easier way to do this. And if you think about doing a long division, you always start from the left. So that's what we're going to do with our divisions. So let's pick another one. We want to start here. This is pointing here, so we're going to start from the left and work our way along. So you can see here that column 13 is lined up with column 6, so we have to input our numbers into column 6. So let's do the classic 355, so I need to put my decimal point here, 355.0. We'll pop that into this register. We'll do the same thing, 355.0. We need to reset these two registers. and we're going to divide that by 113. So again we have to go to column 6, 100, is it 130? No, it's 113, isn't it? Okay. So let's set our decimals. We've got 3 decimal places here. We've got 10 decimal places here. And therefore we require 7 decimal places here. Splendid. Let's start. So we start doing our subtractions. Now, the bell rang. That means that we've subtracted too far. If I add that back again, you can see you can't subtract 113 from 16. So we have to move on over. It's quite handy. You can either keep an eye on here. Let's move over 1. So now we're removing or subtracting 113 from 160, so that's going to be okay. Oh, the bell rang, add it back. It's easier just to keep going till the bell rings rather than keeping an eye on this, to be fair. So we'll do that again, and add it back. Subtract until, and then add it back. 3, 2, 1. And keep going. So, what's the answer? The answer is 3.1415929, which is a pretty reasonable approximation of pi for such an old calculator. And of course we've got some leftovers, 0.00000023 remaining. Obviously, being an infinite number, we would go on infinitely trying to figure that out. But yeah, so that's how you do your long divisions. You start from one side and work your way along. So let's reset. That's the 4 basic operations of a mechanical calculator. Okay, just at the end of the video I thought I'd do a couple of more fun calculations and demonstrate a few extra functions of the calculator. So let's say we wanted to take a big number like 3,803. 3803. We want to multiply by that by, say, 3607. So we want a 7 in this column here. But rather than just turning it 7 times, which is a way to do it, we could add it 10 times and remove it 3 times. And that makes it much quicker to get to these higher numbers here. It's called shortcut multiplication, and it's one of the extra benefits of having the tens carry in this area here. So we're going to multiply that by 3607, so we put a 6 here and a 3 here. So 3803 multiplied by 3607 is this big number here. So let's copy that up to there, press the back transfer, do the reset, number comes up here. So let's multiply that by 9, so I could multiply it by 10 and subtract it once. And we get 1, 2, 3, 4, 5, 6, 7, 8, 9, which is fun. Again, copy that up there. And let's say this time we want to multiply it by 8, and then add 9. And we get 987, 654, 3, 2, 1. Awesome. Just fun you can have with numbers. Okay, another fun thing you can do is working out square roots. An interesting thing about square roots is that if you if you add up all of the odd numbers that precede it to make its total, I'm not explaining it properly, but it will become apparent, sorry, then you will end up with the square root. So let's have a look. I've just added up the first 4 odd numbers and they total 16, and the square root of 16 is 4. So let's add another odd number, 9, we've now got 25 here. The first 5 odd numbers add up to 25, and the square root of 25 is 5. This basically goes on forever. I keep adding odd numbers, and another odd number. Here we go, and another odd number. I've now added 9 odd numbers together. Their total is 81, and the square root of 81 is 9. This always works. So we can use this to calculate the square root of a number. So we'll do it like a long division and start over here, which means we have to work from column 6 again to line up with column 13. So let's put a big number like 45,369 in. We go 45,369. We need a 0.0 here. So we're going to need one here as well. I think. Well, we'll figure that out in a minute. Yeah. So pop that down there. 45,369. So we've got 8 decimal places here. Okay. So let's reset here and here. And we'll start subtracting our numbers. So back to column 6, we'll subtract 1, subtract 3, subtract 5. The bell rang. We've subtracted too many. So we'll add 1 back, go to the next column and start subtracting the odd numbers. We have to move over 1 as well. So subtract 41, 43, too many. Add it back, take that back up 1, take that down 1 and move over 1 and start subtracting. 421, 3, 5, and we've made it down to 0. Let's check our decimal places. We want, well, what have we got? We've got 8 here, we've got 3 there, we want 5 there. So the answer to the square root of 45,369 is 213. And I think that's one of the most fun things you can do with a mechanical calculator. So just to double check that, of course, if you wanted to, we could put in our 213 here. Multiply it by 213 here, and we get 45,369. So I'm happy with that as an answer. There are loads of other things that these calculators can do. There's working out wages, for example, percentages, compound interest. You can do everything on these, but we'll keep the video relatively short and end there. Thank you very much for watching, and I'll probably have some more exciting old calculators to look at in the future, so please subscribe. Thank you. Bye bye.